reason, vector has to be measured by the coordinate. So we have to invite the appropriate coordinate every case. So you have to draw it, right? If you have a coordinate, you have to express something according to the coordinate. Coordinate has a direction as well as a magnitude. Okay, now, what kind of coordinate we would like to invite in this case? Let's invite this is coordinate to express those graphically expressed equation of principle of impulse and momentum. Then what I can write is, this is mv2 plus what is the impulse? That is something has been acting on these two mass together. Therefore, this is 0 because the forces are internal force. Okay? Of course, if you consider each mass separate, this one is not 0. Okay? And that is equal to mv2 prime plus mv1 prime. Okay, then unknowns are v2 prime and v1 prime. And we have one equation, therefore we have to invite another equation. What is it? That has to do with how these two masses collide each other. What kind of condition it has when it collides each other. Therefore, we invite coefficient of restitution. That is simply relative velocity before impact and the relative velocity after impact along the line, normal line. In every case. Okay? So what coefficient of restitution says? What is this in this case? Relative velocity, and also those velocities has to be always positive. Okay? So what is this in this case? V2. Because mass 1 was in stationary. What is this case? Relative velocity. What is this case? Maybe V capital 1 prime is greater than V capital 2 prime. That's not likely possible. Why that's not likely possible? Okay, you can just say V2 prime minus V1 prime. Okay, and then you assume, this is the assumption, that you assume that V2 prime is greater than V1 prime. And that assumption is very just. I mean, we can justify it. If V1 prime is greater than V2 prime, the mass 1 has to pass the mass 2. That is not allowed in this kind of dynamic problem. Some other problem, it could be possible, but we do not allow it. So we have one more equation, and we have two equations, and we can solve it. Okay? What if for the special case E equals 0? If E equals 0, then V2 prime equal to V1 prime. Therefore, this one equal to that one. Therefore, the velocity of V2 prime is half of the velocity of this one. So that physically means I have two mass, and this one mass will stick to that mass. Therefore, the velocity has to be reduced by half because of conservation of linear momentum. Okay? What if E equal to 1? Then, according to this mathematics, V2 is equal to V2 prime minus V1 prime. So I go over this mass, and this all mass is same. So V2 equal to V2 prime minus V1 prime. And I have another equation, V2 is equal to V2 prime minus V1 prime. So if I add these two equations together, I got V2 equal to V capital 2 equal to V2. And then I plug that value over there, then V1 is 0. That means if E equal to 1, elastic collision, then like that. Okay? Then let me ask you further question. You have many, say you have n pendulum, and you raise this pendulum over here with the height of h, and if E equal to 1, what would be the height of this pendulum would be when this hit this ball? Huh? H. Why? You have to explain why. Why? So which law you are using? 1, 2, 3. 2? 2 and 3? So you have to use 2 and 3. Anybody who think that you can just use the number 3, then we can get this solution? I think I can just use number 3. I said, because there is no energy loss, I can argue that whole system's energy has to be conserved. Therefore, the last pendulum has to move up to h. That is also a possible argument. Right? So you can use only number 3 principle to get the solution. Okay, second question. What if E equal to 0? What the elevation of this last pendulum will get? Huh? Anybody can answer? What it means by E equals 0? Plastic impact, right? What it physically means. Okay, back to this definition. E equals 0 means the relative velocity after impact is 0. That means what? So somebody say, because the relative velocity after impact is 0, therefore this one has a velocity of 1/2 of that velocity, and then 1/2 and 1/2 and 1/2. Depending on the number of n, the velocity would be 1/2 to the minus n velocity. Do you think that is possible? That is correct. Or somebody said, oh, because the E equals to 0, therefore the whole thing will stuck together. Therefore the velocity should be n times m has to be equal to, because the momentum has to be conserved, that is mv1, therefore n, and then this is final velocity, therefore final velocity would be v1 divided by n. Which one is correct? Okay, that is a very interesting question.